record and share my screen. So today's Zoom is going to be short, like I mentioned yesterday, because my B-Day students are going to be taking a walk in the woods here momentarily. And don't forget, A-Day students, you guys will be outside on Thursday, okay? I did post a little reminder here on the stream, but let's go ahead and take a look at our checklist for the day. Week 8, Tuesday. Okay, so I'm going to start class by going over our TQ from yesterday, 4.1, which dealt just a little bit with plate tectonics and the different plate boundaries that exist out there. Okay, and then I'm going to take the B-Day students out for their forest and soil survey. And then for the A-Day students and virtual academy students, when I release you from our Zoom, I would like for you guys to immediately watch both AP daily videos, 4.2 video 1, 4.2 video 2. Both of these deal with the formation and erosion of soil, two very, 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 very important quintessential aspects of any environmental science class, and a topic very dear to my heart. There's also a reading, soil erosion, the cause and effect, as well as a TQ with 3 questions dealing with topic 4.2, soil formation and erosion. Now, for those of you guys that are right here with me right now, those 2 videos, that reading, and that TQ will be something you need to either take care of this afternoon or tomorrow, okay? So that's the only way we can really make it work, so that we can have these labs, these activities, these walks in the woods, these forest surveys, working in the garden, is some of this is gonna have to fall on your off days. Now, what I went ahead and did, like I said I was going to, is I changed the due dates for 4.1 and 4.2 for Wednesday, right? Wednesday night. So from now on, anything I assign on a Monday or a Tuesday will be due on Wednesday. So it gives you a little bit of wiggle room, right? Because some of you guys might be playing sports, and on like Monday night, you might have a game. You don't get home till like 8 o'clock at night, and you're like, oh, I just don't have time to do this right now. You could do a little bit on Tuesday and finish it up on Wednesday. Anything that I assign on Wednesday, Thursday, and Friday will be due on Friday now, right? And so this might help some of y'all. In other words, you ask yourself on Monday or Wednesday morning, all right, what do I need to get done today because it's due today? And same thing on Friday. Now, I would strongly recommend not being like, okay, I'll do all the readings, I'll watch all the videos, I'll answer all the TQs on Wednesday night, because it's not going to get done. And you guys, you're beyond the point of me holding your hand and walking you through this, right? I've given you 1 warning, 2 warning, 3rd chance. I've given some of you guys 15 and a half chances, and we're just we're too far into that, right? We're just too far into it, and I just can't keep it's not fair. It's just not fair to the people who are getting it done and haven't missed a single assignment, and they're playing sports and doing all the same things you're doing. And some of you aren't even communicating as to why you're not getting certain things done, and that's problematic, because you know you're not doing it. You know that I know you're not doing it, and you're not even bringing up that conversation. You can't just sweep it under the rug. It's not going to disappear. I'm not a middle school science teacher. I'm not just going to pass you because it's easy. I've failed people all the time in AP because it's a lesson learned. Like, next time, maybe don't take an AP class if you're not ready for the work. Now, I do want to point out what's going on tomorrow. Wednesday is asynchronous. And there's a very, very short, but very, very important, impactful little documentary I'd like you to watch called The Forest Man, right? It takes place in the northeast corner of India. And it deals a lot with growing populations and the relationship that these growing populations have with the surrounding ecosystems, but more importantly, the soil. So take a look at that. And then there are 2 short readings, one about the significance and importance of soil, like, so what does soil really provide us? And it's not just one thing. It's not just for plants. There's a lot of other things. And then there's a short reading about conservation. So what can we do to kind of reduce erosion? What can we do to protect our soils, right? And then on Thursday, obviously A-Day students will be doing their forest survey. B-Day students, you guys will be doing a little bit asynchronous work. And then on Friday, we'll all come together via Zoom and we'll talk a little bit about soil formation, erosion, the properties, and everything like that. Okay. All right. So I'm going to pause my share real quick so I can pull up my AP classroom and let's take a look at the questions you completed yesterday. I know that diagram was a little wonky, but I do enjoy diagrams that kind of challenge not only your content knowledge, but also logic, right? You really have to kind of reason your way through it. All right. So I'll resume my share. We'll go to the question bank. And so again, those two videos are already assigned to you in AP Classroom. I can see who watches them and who doesn't. Okay, let's see. Come on. All right. 4.1 second period. Looks like we had almost perfect participation. There were still 4 individuals that decided they were above the influence of environmental science and decided that they just didn't want to do it. They wanted to catch a 0 for it. That's okay. It's a decision we all make. Let's take a look at quake formation. So here we got this crazy diagram talking about plates. We got 3 plates, plate 1, 2, and 3. Now, the interesting thing about this diagram is it does give us some relative movements. You know, we can see that plate 1 is moving this direction. If you think like north, east, southwest, let's say it's moving in the east direction. Same with plate 3, so they're both moving in the same direction. And then plate 2 is moving in a westerly direction, or west direction. And we're asked about these different labeled boundaries. What's going to go on? What are we going to find there? First question is, at which of the following sites is an earthquake most likely to occur as 2 plates slide past one another? So when plate boundaries slide past one another, we call that a transform boundary. And transform boundaries can create some pretty heinous conditions for earthquakes, right? Transform boundary results in earthquake in Haiti. And then we got the San Andreas Fault, which is just an accident waiting to happen. And so where we see 2 plates gliding past each other, and it wouldn't be smooth, would be C. What do the double dotted lines mean? So again, this is where it's kind of testing your logic. Okay, so you see that plate 1 is moving in this direction, plate 2 is moving in this direction. Now, the dotted lines here are signifying the fact that plate 2 is sliding underneath plate 1, because remember, plate 1 is moving this direction. So plate 1 and plate 2 are moving at each other. This is simply just telling us that plate 2 is sliding underneath, right? Now, let's take a look at the next question. That is a good question, though. Hold on, rephrase that. What matters all that much? Oh, does it matter whether or not you understand which one's going under which? Not necessarily. Oh, okay. Sounds good. As long as you recognize that it's a convergent boundary. Which of the following sites would result in volcanoes, island arcs, and mountains, right? So mountains and things like that are generally going to form where 2 plates are pushing towards each other. Now, they don't always both push upwards. Usually one plate is more dense than the other, one is thicker than the other, and the densities are going to determine which plate maybe rides on top and which one subducts or sinks beneath the other back into the mantle. And so if we look at plate 2 and plate 1, they are moving in opposite directions. And in this particular position right here, plate 2 is sliding underneath plate 1. Plate 2 is subducting underneath. And as it subducts underneath, it's going to cause plate 1 to kind of buckle up a little bit, which will result in mountains. And it could also result in volcanism, right? Obviously, some magma is going to be able to find its way up into a chamber, right, from the mantle because the rock is fracturing the boundaries right there. And then we could get island arcs, right? So we don't know, but plate 1 and plate 2 both might be oceanic plates. And if they're both oceanic plates, what we usually see is one oceanic plate subducts and creates a trench. You can kind of see where it's bending down and getting peeled back right there. And then you can see how my knuckles kind of push up. And those knuckles would push up like islands. And they usually create an arc, right? Or like a straight line of volcanic islands right above where that subducting plate is creating that trench. So usually when you see an island arc like Japan, there's also a trench that goes with it. When you look at the Mariana Islands, you have the Marianas Trench, right? So you have this trench where it's subducting, and the resulting volcanic island arc. And let's look at the last one. Which of the following would result in seafloor spreading? So seafloor spreading is kind of what we see at divergent boundaries where plates are moving away. Famous example is the Mid-Atlantic Ridge, actually where this first idea was first hypothesized and observed. And so we have to find, okay, which plates are moving away from each other, okay, to create that seafloor spreading where magma could potentially rise up and create some volcanism or geothermal activity. Well, if you look here, again, plate 2 is moving in this direction, and plate 1 is moving in this direction. So even over here, plate 1 is still moving this direction, and plate 2 will be moving away. And this right here will be brand new rock from cooling lava. And this would be where we would find, something like the Mid-Atlantic Ridge, the East African Rift Valleys, the Rift Valleys that we see in the island of Iceland, because it sits on top of that Mid-Atlantic Ridge. You got two boundaries moving away. Obviously, magma can reach the surface, turn to lava, cool, and solidify into new rock, and that pressure pushes the plates continually away from one another. In fact, the rising magma and cooling magma up here is what creates the pressure that drives the movement of plate 2. And then once plate 2 starts to subduct, we've got those convection currents inside the mantle that can actually kind of pull that subducting plate down. And that's why we get all this dynamic motion of the tectonic plates. All right, so that's all I have for our Zoom today, right? Because I'm going to take these guys out in the woods. Make sure tomorrow, don't forget about your Forest Man documentary. For those of you at home, go ahead and start watching those AP Daily videos. Go ahead and get that reading taken care of and those TQs. Remember, the TQ, the due date is tomorrow, not today. But you'd be happier if you got it done today. I'll be honest, okay? Well, that's all I have. I hope you guys have a wonderful day. And I'll talk to you tomorrow, and I'll see you on Thursday. Don't forget to dress for the weather, my A-Day students. Let me stop.